Hello, in this video we are discussing twiddle factor or a phase factor. Twiddle factor is very important in fast Fourier transform algorithm FFT algorithm to calculate DFT of a signal. Let's first check what is the definition of DFT in terms of twiddle factor. Definition is x of k is equal to summation n varies from 0 to n minus 1 x of n W capital N Nk, that is the twiddle factor, where k varies from 0 to n minus 1. So this twiddle factor in fast Fourier transform algorithm is a trigonometric constant coefficient that are multiplied by data x of n. Now let's understand what is the value of this twiddle factor. This W twiddle factor, its value is e raised to minus j2 pi. We know how to calculate e raised to minus j2 pi. Cos 2 pi minus j sin 2 pi. Sin 2 pi is 0 and cos 2 pi is 1. That's why twiddle factor W, its value is 1. Now let's check what is the effect when we will add this capital N and Nk along with this twiddle factor. First let's check N. W N. N represent the N point DFT. E raised to minus j2 pi is W and this N will come in the denominator. So e raised to minus j2 pi by N. What is the effect when we will add k here? So W N K is e raised to minus j2 pi for W. K will come in the numerator and this N will come in the denominator. E raised to minus j2 pi k by N. Now you can easily write W N this Nk. E raised to minus j2 pi for W. This Nk will come in a numerator and this capital N in the denominator. So this is Wn Nk. Now let's check what is the value of this Wn Nk for different values of n. Let's start with n is equal to 2. That is 2-point DFT. We'll first draw phasor diagram. We know phase for discrete time signal varies from 0 to 2 pi. Range of the frequency for discrete time signal is 0 to 2 pi. After each 2 pi, spectrum repeats. So we'll start from 0 and this one cycle means 2 pi. So this is 0, this is pi. Then for 2-point DFT, we need only two samples. One is at angle 0 and another is at pi. What is the value of this? At 0, value is 1 and at pi, value is minus 1. How it is? Let's check. For 2-point DFT, twiddle factor is W, capital N is 2 and this K is 0. Its value is W is e raised to j2 pi. This 2 will come in the denominator and 0 will come in the numerator. So e raised to, it becomes, because of 0, e raised to minus j0. And what is e raised to minus j0? Cos 0 minus j sin 0. Sin 0 is 0 and cos 0 is 1. That's why W20 is 1. See, angle is 0. At angle 0, your value is 1. Similarly, another W21, e raised to minus j2 pi. This 1 and 2. 2 will get cancelled. E raised to minus j pi. So cos pi minus j sin pi. It is sin pi is 0, cos pi is minus 1. So at angle pi, value is minus 1. So we can write here W20 and in a clockwise direction, second sample is at angle pi, that is W21. So these are the value of twiddle factor for capital N is equal to 2. Now let's check N is equal to 4 for 4-point DFT. Means there are 4 samples from the range 0 to 2 pi. First sample, second sample, third sample and fourth sample. And angle are 0, pi by 2, pi and 3 pi by 2. First, second, third, fourth. These are the 4 samples. What are the values? We know real values 1 and -1 at 0 and pi. Then for imaginary pi by 2 and 3 pi by 2, it is -j and j. Let's check twiddle factor values. 4 twiddle factor W40, W41, W42 and W43. So W40, we know how to calculate. W is e raised to minus j 2 pi. This 0 in the numerator, 4 in the denominator. Now it becomes e raised to minus j 0. We know cos 0 minus j sin 0. Cos 0 is 1, sin 0 is 0. So this W40 is 1. Similarly, W41, let's put the value. 1 is in the numerator, 4 is in the denominator. It is e raised to minus j pi by 2. Angle is pi by 2. Here angle is 0. So e raised to minus j pi by 2 cos pi by 2 minus j sin pi by 2, and it is minus j. Similarly, W42, this 2 into 2, 4, 4, 4 will get cancelled. It is e raised to minus j pi. So cos pi minus j sin pi, it is minus 1. Similarly, W43 is, it is j. So you can check here 1 angle 0 pi by 2 minus j, then pi minus 1 3 pi by 2 j. So you can write here W40 1 2 3 in a clockwise direction. Start from angle 0. So W40 1 2 3. Now twiddle factor property is it is periodic after each capital N. So here N is equal to 4. So after each 4 twiddle factor it repeats. Means what? W40 and W44 is same 1. Similarly W4 1 and 5 is same. Similarly W4 2 and 6, 3 and 7. So after each 4, again the value repeats. So similarly here W4 8 is same as W40 and W4 4. Now twiddle factor for n is equal to 8. Now there is no need to calculate with the e raised to minus j formula. You need to just remember phasor diagram each time. So you have to start from angle 0. Now n is equal to 8. Here we need 8 equal parts. So we'll take 8 equal parts, and then this angles you need to find values. So this is 1 at angle 0, then 1 by root 2 minus j 1 by root 2 minus j, then again 1 by root 2 1 by root 2, only sign changes, minus 1 minus minus 1 j and this one. So you can check, we know these values. Real axis 1 minus 1 angle 0 pi, then minus j j angle pi by 2 3 pi by 2. Now these diagonal angles and value you need to remember. See, the trick is in each diagonal value real part is 1 upon root 2 and imaginary part is also 1 upon root 2. Only the sign of real and imaginary part changes. So how to remember this? Real part you can check here. Real axis positive, so real value positive. Imaginary axis negative, so imaginary value negative. Here real positive, imaginary also, sorry, real negative and imaginary also negative. Here real is negative, imaginary is positive. Here real is also positive, imaginary is also positive. So for this diagonal value also you need to remember real part is 1 upon root 2, imaginary part is also 1 upon root 2, and sign you have to consider according to its position. Now we need to write W, twiddle factor. So W8, so W80, go clockwise. For each point we'll increase this numerator. W80, W81, W82, W83, W84, W85, W86, W87. So this is the easiest way to remember the values of TwiddleFactor. Always start from phasor diagram, angle 0, pi, values are 1, minus 1, then pi by 2, 3 pi by 2, minus j, j. These are the 4 points for n is equal to 4. Then for n is equal to 8, we'll add this diagonal values also and diagonal points. And these values are real part is 1 upon root 2, imaginary is also 1 upon root 2. Only sign you have to consider according to its position. So the values you can cross check. Same method which we have referred previously. So this is a way we can remember the TwiddleFactor values in an easy way. Thank you.